We are still talking about significant figures. We have already covered the concept of significant figures. Then we discussed identifying significant figures. We then looked at working with significant figures. And now we will be talking about rounding off of numbers. After which we will deal with standard form, sometimes known as scientific notation. Rounding off. When you do a calculation, you may need to round off the answer to a particular position, as in the case of significant figures that we saw in the last video, or based on place value, which you may be given, and you may have learned to do that in primary school. Recall from the previous video, we said that if you had to divide 500 cubic meters by 1.234 square meters, you put that in your calculator. At least in the calculator I have in this computer, I get this answer. Well, this is what we are not to do. We are not to write down all of those numbers. But what exactly does rounding off mean? So let's consider this as we round off some numbers based on place values first, after which we will review those 3 rules that you may have learned in primary school. So based on place value, suppose you have this number 4,367.952, which is this number. If you space it out, we know that the 7 is in the ones position, the 6 is in the tens position, the 3 in the hundreds position, the 4 in the thousands position, and we can keep going that way to the left. If we go to the right, the 9 is in the 1/10th position, this 5 is in the 100 position, this 2 is in the 1000 position, and we can keep going like that to the right. Suppose you are asked to round off this number, 4,367.952, to the nearest ones. The nearest ones, that's the nearest whole number. So you're asked to round it off at this point. Let's draw a number line and put in the relevant numbers. Let's say this point here is 4,367, and this line here is 4,368. Now obviously if it's 4,367 point something, our number will fall somewhere in between that 67 there and this 68 here. So this would be the exact halfway point, 4,367.5, and then you have 7.1, 7.2, 7.3, 7.4, 7.6, 7.7, 7.8, 7.9. Let's see which point this 7 is closer to. So we have to round off this number to the nearest ones. That is in this position. This 7, which one is it closer to? Now we look at the digit immediately to the right, which is 9. And that would place us at this point here. So when we consider the distance from here to there and the distance from here to over here, you will notice that that green line is much longer than this blue line. Therefore, if we have to round it off to the nearest ones, it would be 4,368, because the number is closer to 4,368 than to 4,367. So is it closer to 4,367 or 4,368? Obviously, the answer is 4,368. So if we round off that number to the nearest ones, this is our answer. To make matters a little more clear, if we take those 2 digits, 0.95, so now we are even closer, we're even now closer to this number, and we have moved a little further from that one. So our answer is 4,368 because is the closer ones. Let's look at another example. This is a slightly different number. We already looked at this. 7 is in the ones position, 6 in the 10, 3 in the 100, 4 in the 1,000, 8 in the 1/10, 5 in the 100, and 2 in the 1,000. This time we have to round up this number to one decimal place. So actually we are rounding off at this position, one decimal place. From that point, that decimal, you have one space. So if we write our numbers again on number line, this time 4,367.8 is here, 0.81, 82, 83, 85, 86, 87, 88, 89, 0.79. Now again, we looked at the digit on the right of the 8, just the first digit, which would be 5. In this case, it's a little past 5, so here. So the question we are going to ask ourselves is this. Is this number, 4,367.852, is it closer to this number here or to that number there? As you can see, that blue line up there is a little shorter than the green one. And so, when we consider that 5, which is it closer to? We find that the answer is 4,367.9. It's closer to 4,367.9. So that is our answer. We have to round off this number to one decimal place. So we have to round off here. We looked on these numbers on the right, especially the first one, maybe the second one too. And that will help us to decide whether we go over from the 8 to the 9 or we stay with the 8. As we can see, it is closer to the 0.9 than to the 0.8. All right, let's consider now that same number, but now to two decimal places. We already know how this goes. Two decimal places, 1, 2. So we are rounding off here. We are rounding off there. If we set up our number line, 0.85, 0, 0.851, 852, 853, 855, 85, and so on, 0.86. Now we look at the number, immediately we get 2, which is here. So we ask ourselves, is that number closer to this or is it closer to this? As you can see, it is closer on this side. And so when we say we are rounding off a number, we mean which number is that position closer to. That's what we mean. So that in this case, our answer would be 4,367.85. This answer. So we are rounding off here for two decimal places. That is two digits on the right of the decimal. We round off at this 5. There's a 2 here. That 2 is less than half, so it's closer to 85. So our answer is 4,367.85. Now, if you have to round off to the nearest tens, in this case, we are rounding off here. We set up our number line again, 4,360 because we're going in tens, and we go over here to 70, we go in tens. That will be 4,365, and of course you have these others between here. We consider the digit immediately to the right of the point that we are rounding off. So we are rounding off at 6. We consider the digit immediately to the right of it, which is 7. And that takes us here. Are we closer to this 10 on the right hand side here, 4,370? Or are we closer to this 10 on the left hand side here, 4,360? As you can see, that green line is longer than this blue line. And so you could even take into account the two digits on the right hand side of the where you are rounding off. But really all we need is 1, just a 7. But if we take 7, 8, we notice that we are even a little closer to this side than the other side. 4,360 or 4,370. And of course the answer is 4,370. So that is what we mean by rounding off. Let's round this off to the nearest hundreds. Same number. The nearest hundreds is here. So 4,367. Again, we set up our number line. Nearest hundred. So 4,300, 4,400. This is 4,350. 4,310, 20, 30, 40, 50, 60, 70, 80, 90. 4,400. Again, we look at the digit immediately to the right of the position we are rounding off. We place that on this number line, which is 4,360, which is here. So is it closer to 4,400 or 4,300? As you could see, that blue line is shorter than the green line here. So our answer will be 4,400. To reinforce that, 4,400, if we consider the two digits to the right. Now, remember I said all you need to consider is the first digit on the right of the position you are rounding off. But if we consider the two digits here, 67 is going to take us even closer to this end. So 67 would be somewhere here. That is now even closer to here than to there. But all you need to do is to take into account the first digit on the right of the position that you are rounding off. Now, how about if you have the same number and you want to round off to the nearest thousands? So we are rounding off here. Our number line, since we are going in thousands, we'll put 4,000 here and we'll put 5,000 here. That's halfway. Are we on this half? If we are within this half, we will say 4,000. If we have passed that 5 and we are on this half, we will say 5,000. So that's 4,102 and so on. So the first digit on the right of where we are rounding off is this 3. Let's place this 3 here, which is here. So as you could see, we haven't reached halfway yet between 4,000 and 5,000. Therefore, we are closer to 4,000 than 5,000. That green line is much shorter than this blue line. So closer to 4,000 or 5,000, answer is 4,000. So if we were to round off this number to the nearest thousands, this will be our answer. Now, if you take the 3/6, the two digits, remember I said all you need to do is take into account the first digit on the right. But if we take the two digits, then we are here, not quite 400. We are still within this half of our number line. So the answer is still 4,000. Let's summarize what we have learned about rounding off so far. First, we said if the digit to the right of the place value at which you want to round off is less than 5, if it's less than 5, you drop that digit and any others to its right. So for example, you have 34.398 and you want to round off at the ones, which is here. This digit here is 3. You just drop the whole thing and you get 34. In the case of this number down here, you want to round off at the hundreds, 300. The digit we're considering is 2. It's less than 5. So you just drop everything there. But you have to remember to add zeros to keep the place value, so that this 3 must still be in the hundreds position. And to do that, you have to add 2 zeros. So our answer is, now if the digit to the right of the place you are rounding off is 5 or more, you will drop that digit and any others and add 1 to that position. So if you have 34.798 and you want to round off to the nearest ones, which is here, you look at this digit and it is 7. So that is greater than 5. So you will drop everything here and increase that 4 by 1 and make it 5. So in this case, 385.789, you want to round off to the nearest tens. That is here. You're rounding off here. You look at this digit to the right and it is 5 or more. So you will drop everything here and increase that 8 by 1, which becomes 9. Remember to add a 0 to keep the decimal place, the position. So those are the two rules. And the third one we have been looking at all along the way. If you are rounding off at positions of 10 or higher, remember to add zeros to keep the rounded off digit in its original position. We had an example here with that 390. We had an example here with that 300. And now, if you have to round off 468,935.789 to the nearest 10,000, that is this position here, the digit immediately to the right is 8, so you would increase the 6 by 1, so that will give you 7. You drop everything on this side, but remember to add zeros so that that 7 and that 4 are retaining their original position. So I have seen many students do this. They say, okay, that is 8, we make this 7, and they say the answer is 47. No, you have to add 3 zeros to make sure that this 47 stays in the original position. So, based on place value, I want to emphasize one point. If you are rounding off from the ones this way, you don't have to bother about adding zeros. However, if you are rounding off from the tens, the hundreds, the thousands going that way, remember to add zeros. So if you were to round off this number here at this position and you get 4,000, you get 4, 5, and you were to drop all of those, remember to add 2 zeros here so that that 5 will stay in the hundreds position and this 4 will stay in the thousand position. Students generally forget that. This is Microsoft Excel. I divide 34 by, and I get this answer here, and I ask to round it off at 2 decimal place, and it gives me this 0.86. 0.86. So it took that 7 and increased that by 1. Same number, 1 decimal place, it says 4.9. So evidently it took this 5 and add 1 to that 8 to give us 9. Same number, and we want 0 decimal place. So as you could see, the answer is 5. So it take all of that out, take this 8 from here, this is more than 5, make that 5, so you get 5. Now if I had said 3 decimal place, 1, 2, 3, so we are going to round off here, this digit is 1, so the answer is 4.857. And so on. Now 5 decimal places, 1, 2, 3, 4, 5, that's this 4 here. Obviously it's dropped that. And the answer we got this. Now this is from Microsoft Excel. If you divide 25 by 2, you get exactly 12.5. If you say 1 decimal place, yes, it will tell you 12.5. If you say 4 decimal places, it tells you 12.50000, so it is exactly. Now if you say no decimal place, because it says this is 5 or more, it actually increased that 12 to 13, and that's what we get here. So the Microsoft Excel uses the same rule that we are going to use for CXC. Now that was rounded off based on place value. Now we turn our attention to rounding off based on significant figures. Since we already know how to round off based on place values, we use significant figures to determine which place value to round off at. So basically, we have done this already. If you need to round off a number based on a specific number of significant figures, Count each digit except leading zeros from left to right and stop at the required number of significant figures. Round off at that position. Now we know how to do this. We just looked at that. For example, if you have this number here and you want to round off to 4 significant figures, you count 1, 2, 3, 4. This digit is greater than 5. Drop everything here and increase that 7 to 8, so we get 4,368. Next example. If you want to round off that same number to 2 significant figures, you count 1, 2, and you have to round off where that 3 is. The digit on the right is 6. So we will drop all of this, increase that 3 by 1 to make it 4, and remember to add zeros for those 2 positions. Another example, if you have this number here and you want to round off to 2 significant figures, remember leading zeros don't count. So we count 1, 2. We are rounding off where that 4 is. The digit on the right is 2. So we will drop everything there and our answer will be 0.0034. Last one. Let's say you want to round off the number 5,600 cubic meters to 3 significant figures. You count 1, 2, 3. You have to round off at this 0 here. Now we have a problem. We can't put a point anywhere here because we will change up the number. In this case, we will have to use standard form and write it as 5.60. That's our 3 significant figure times 10 to the 3 cubic meter. If you don't know about standard form yet, that is the next thing we will be doing. Or you could have written it as 5,600 plus or minus 5. Now, if you have it plus or minus 5, it means if you double at 5, you will get 10, so you are rounding off at the tens position. That is what it means. But it's better to do it this way if you know how to do it that way. As I said, right now, if you don't know anything about standard form, sometimes called scientific notation, don't worry. That is what we will learn about next. We covered that and this significant figures. We just talked about rounding off of numbers, what it means, how to round off based on decimal place or significant figures. And next we will talk about standard form, sometimes called scientific notation. And that brings us to the end of this presentation.